Yo, what's up? Hope everybody had a great weekend. So let's continue on this cliffhanger I left on last Friday. So we're currently doing or extending the mesh parser with some bisect and build methods. Because we're gonna rename the mesh parser as well. It's gonna be, I don't know exactly what we're gonna name it, but it's gonna be our procedural mesh generator class, pretty much. So not only a parser anymore. And if I recall correctly, I think we implemented we have implemented the bisect method fully. And what I want to do now is I just want to test it. Yeah, the last thing we did was get mesh here. So slice, we have a positive and a negative part. And then we have the slice vertices. That's the new vertices we create on the slice plane, or where the plane overlaps whatever this mesh is. And we have a boolean that checks if a triangle is on the positive side. And we check if that's the case. We check if, or for each triangle, we check if they're intersecting the plane. If they are, we slice the triangles, and then we add to the positive and a negative, and we add the slice vertices to our slice vertices. If the plane isn't intersecting the triangle, we just add the triangle to either the positive or the negative mesh parser. And then if fill slice hole, then we create a slice polygon from the slice vertices, and then we add these polygons to positive and negative, and then we return both of these. So given a mesh parser we call slice, we return two new mesh parsers. We pretty much don't do anything with the mesh being sliced. I wonder if we're going to implement a couple of variants on this slice. Okay, let's test it. Actually, let's duplicate these. Okay, so we're gonna have to. This sphere is gonna be a mesh parser. Yo, what's up, PG King? Good morning, good morning. Hope you had a wonderful weekend, man. We're gonna have to convert this one to a mesh parser. I think that's should be pretty straightforward. Let's do it like this. And good morning, Harukanan. Hope you had a wonderful weekend as well, man. Best, yeah. It was all right. That's still nice, I guess. And let's duplicate this one and call it mesh parser slice test. Harukanan fast dog yesterday, so got a nice breakfast made for me. Beautiful. Love to hear it. I got some cupcakes, which I'm happy for. What is happening? My keyboard changed to English. Okay, let's try it now. There we go. Okay, I guess we're gonna take mesh filter, mesh filter. We're gonna call it mesh to slice. Plane. When we get this like going, the slicing, like I'm looking forward to when we can do when we can do multiple slices after one another. So we take a sphere which we generate and then we slice, randomly slice. It's gonna be nice. Just see how it takes shape. Oh yeah. Mesh to slice and plane. We want to create the plane as well. But we want it with game, misc, shapes, plane. Oops. Oh yeah, of course. Actually, we're gonna change this one to transform. Oh, do we have to do size here? Azad Ziad, what's up? How do you create terrains? Do you consider them an entity? Is it collidable? Yeah, we just generate it based on height. Pretty much. And I consider it a static entity. And it is collidable. Currently, it's collidable by a mesh collider. But it's going to be height map collision later on. Okay, I thought I had... okay. So if we want it infinite, we just do 0. And then we slice, and we want to slice parser and plane. Sorry. Monday morning. And we want to fill. There we go. Parser.slice plane true. Then we have positive and negative. Hopefully this will work. I always forget, is it just new game object? I don't really care about material right now, I don't think. Something like that. Let's try it. Yes. Don't we have any? Yo, what's up, Antonino? I'm good, I'm good. How about you? Okay, this is rough. But we can probably get to the bottom of it. What I think sucks here is okay, we're gonna try one thing here. I think that the culprit is this one. Antonino, yesterday I decided to start a game myself. I want to take this seriously. Damn, nice to hear, nice to hear. Good luck and keep me posted. So yeah, I'm pretty sure this is or more specifically this one then, I guess. Trying to figure out how we can properly... Let's take a quick look at it again. Let's take a look here. What happens? Hmm. Nah, it's probably not get mesh. Everything else works just fine, but not these. I want to see. Let's try and do. Let's see what happens if we do balls here. We don't fill the caps. Yeah, you see, we get something. That's not very good. Okay. Hmm. So, triangle slice. Add triangle. Yeah, we should be getting valids all the time. We can double check that eventually. Yeah, we just add it here, and then we add the vertex. And we add it to triangles as well. Okay, that's good. This one works. Okay, I'm thinking that it might be this method. But why? Oh, is this with the fact that, let's see. Edges we always go like this. I wonder if this has to do with, but I think we fixed that one. This. Yeah, I don't see much of a problem here currently. We add them in the wrong order later on, I don't think so. Just gonna take a look at mesh tests that works. Hmm. What the fuck is going on here? Okay. Okay, what can we do? How can I print this or test this in such a way that we can get to the error? Is the intersecting plane? We want to create a test with this, I assume. Triangle on positive side. We want to slice triangles as well. These work, right? Yeah, it's just when we start getting to the sliced triangles, right? I'm a little bit worried about this one. Okay. Wanna... Ooh, one sec. Let's see here. Let's add a big mesh parser. We're gonna go to mesh parser visualizer. Let's see, what do we have here? Let's do it here for now. See, how do we want to do this? We want to do minus, positive. Like this, maybe. And that's our triangle. And I want to draw this one. And then I want I wonder, however, if system serializable. Okay, great. Like we want to draw a plane, but we don't have a size. Ah, we can do the size. It's equal to plane, get bound points. Something like that, maybe. Yo, what's up, Spires? Thank you for the raid. Appreciate it. Appreciate it. What's up, Django? Let's see if we can split this one now. Thank you, Spires. You too. Django, what we're working on here is... Oh, where to start? We're basically building a procedural mesh generation system to be able to generate a wide variety of creature models, or parts of creature models, maybe horns, eyes, bodies, you know. So we're implementing a mesh parser class, which, like, it's a more detailed data structure for our meshes, which we can use, which we can slice and stuff like that. And we're currently implementing the slice. So given a mesh, we want to be able to slice it with a plane, and we're having some problems, so I'm just drawing everything and making sure that each step works. Hopefully that summarizes it. Antonino, why I'm the only one from YouTube? I wonder that as well. So let's do... Let's slice this one with this plane, and that's about it. Yeah, we also get new vertices here as a list. Yeah. Slice plane. Okay, now we have two new triangles, and I want to draw those. I want to draw... let's draw one in red. They're gonna overlap this, which is... I will see what we can do about that. And then we want to draw a triangle egg as well. Yeah, we want to do... let's go green here. Yeah, we can see here that, fuck, it already fails here. That's not good at all. Hmm. You know what? We're gonna do this. Triangle slice, visualize. Triangle slice, go original triangle. Yo, what's up, Star Platinum? I'm okay. I'm doing fine. I'm doing fine. How about you? Okay, so now we can toggle a little bit more what we see and what we don't see. I knew it was gonna fail somewhere, but I had no idea that it was gonna be here. So look at this. This is interesting. So this is the original triangle, and we want to slice it. So this is the positive one. That's just the same one. And then we have the negative here. So what the fuck? Triangle slice. And it's pretty weird because this one is straightforward. I did not anticipate this method to fail. Positive vertices, negative vertices, new vertices. So for each edge in the triangle, we do is point on positive side. If so, we add it to positive, otherwise to negative. And then we check if it's intersecting plane. Star Platinum, I'm trying to learn Rust to create a chat app. Oh, that sounds pretty nice. Relaxing. Slicing seems like destruction. Yeah, we're actually going to do destruction to create. Or something like that. We want to procedurally generate meshes, and one way to do it is by slicing a mesh. So for instance, we're going to use it initially to create some stone creatures, and to create the stone models we just add a cube and we slice it randomly a few times, and there we have a stone. And that's pretty much what we're going to use it for initially. After that point, everything is possible. So let's see if this one is wrong or right first. So if we show the positive, get the fuck out. Okay, here it is on the positive side. Negative side, then we only get this line. Okay. And then we take the, so I guess this, we're entirely on the negative side. And now we're entirely on the positive. Okay, we can see here that the, yeah, the slicing sucks. The slicing of the edge, actually. So this one works. Okay, is intersecting plane. If I recall, I think we took this one from here, right? Line direction, plane normal, binormal, line direction. Could it be V2 minus V1? That should be okay. Or could it be that I have screwed up the... P2 minus P1, yeah. I wonder what we want to do. Probably nothing. So what do we have here? Plane and normal, plane origo, plane origin, minus line point. Line point we use v1 position and then divided by dot. Ooh. Yeah. Yeah, we return t. Intersect point. True. Could it be? Nah, I don't think so. Pretty sure this one is okay. Something has to be wrong with it. Actually, let's... In Star Planum, it's just intersection of a mesh with a plane. And may I ask why you code everything from scratch? I'm curious because there's a lot of articles and open source libraries. The slicing library is very lightweight though. Which slicing library? And like, the idea is that we're going to extend this, and we already work with custom classes that holds a lot of information. So I'm not so sure that the third-party solution is correct for us. Although we do have, so we definitely use a reference, like write-ups we use. Open fracture. Yeah, but like, we're gonna use this to generate a mesh, and we're gonna generate a lot of custom properties. So when we slice something, we're gonna assign vertex colors based on how the slice happened, and a lot of like intricate stuff like that. When we slice something, we don't want it to be a Unity mesh. We want it to be something else, so we can work and alter it a bit more. It's a lot of, we're gonna do a lot of other stuff than just slicing. That's like my borderline point. Okay, but let's see here. Currently we can't even get the triangle slice to work out. But actually, I'm wondering about this one as well. What are we actually seeing here? Star Platinum, so you have a sphere and a bunch of planes pointing away from it. We can define the side we keep because the plane points towards the center of the sphere, I think. Or not even, like, the problem is, so look at this, like we have a working solution. Right, so we cut this sphere into two pieces here. But this one works with, in a very, like with a basic, with a raw data pretty much. We just take the vertices that is stored in Unity Engine Mesh and work with that. And what we're trying to do now is we're trying to incorporate it into our custom Clash mesh parser, which uses classes like vertex, edge, triangle, polygon, a lot of more like structures and classes to analyze a mesh so that we can alter it in multiple different ways. So like we know how the algorithm works, we just, like somewhere along the line when we transformed it to our mesh parser class, I made an error. We're just trying to pinpoint that error pretty much. And it's a pretty simple algorithm. We just assume that it always becomes two parts as well, because we're going to do it with, yeah, we do that assumption. And then we just loop through every triangle and see if it gets sliced. If it gets sliced, we slice the triangle. That's pretty much it. But when we slice the triangle like this, as opposed to the other solution, something happens. And I wonder if it's some of the... I cut some corners, maybe, and I'm wondering if it's biting me in the ass now. This one is weird as well. Is point on positive side. Oops. Because this point here is not on the positive side of this plane. So this one should not be included. But for some reason it is. So what the fuck? We do... do we want to do Do we want to do origin minus point? No, I think that should be like this. Right, I just have to check what happens if we do. And what happens if we skip this one entirely right now? We're gonna get invalid triangles, or triangles marked invalid. That's okay. Okay, this works better. We have this point. Why do we have this point? Huh. Okay, this works. Like if we're on the wrong side of the plane, we remove them. That's nice. But I have no idea why we're getting this line here. Oh, oh, never mind. I have. If we try and create a triangle with, yeah, we create new vertex here. So we get 0, 0, 0. Okay, so that makes sense. Just a lerp, that should be okay. So it's how we calculate this t. It has to be. Edge is intersecting plane. T minus 1. Yo, what's up, Chips? I would be very surprised if this is wrong, given the fact that we have worked with it here. I wonder if plain origin... Chips, what's this game about? Think Chow Garden in Sonic. I have some videos about it on my YouTube you can check out. Where I describe it in more detail. One sec. Could it be... Fucking hell, could it be plain... It could very well be that we're not normalizing the normal in this case. Ah, fuck me. Okay, but now it's normalized, but it's still, we still have the same problem, don't we? Yeah, we do. Okay, that was one issue at least. Okay, let's go to mesh test. I want to see. Here it's computed like this. We create array VA, VB minus VA. So that's pretty much, but then they do array cast. Maybe. It's pretty much exactly the same ideas we have. Hmm. Let's see. Uh, let's just start with this. Pretty sure we have it here. I'm wondering what I'm doing wrong. Solve for t. P0 here. So I flip in these, but I don't know. Dot plain normal line direction. We do it here. That's our dot product. We use it here. We have plain normal, plain point, line point. Plain point, line point, plain point, line point, plain normal, plain normal. Exactly the same. We don't do this later on. We do a lerp instead. Is that bad? No, lerp should be totally fine, I think. Yeah, plain point, line point. Yeah, everything is exactly the same. So what the fuck? What am I doing wrong? Still under the assumption that this is where the issue happens. One sec. We just care about parallel. Fucking hell. Could it be? Could it be? Could this actually have been the error when we did tessellation and couldn't get it to work either? That would suck. Still not quite there. Okay, so either origin, position. Nah. So either position, origin, plane normal, or binormal is wrong. In fact, this is weird as hell because with this one here, it's like we're removing vertices. Oh, fuck. How does that make sense? When we create these from lists, we just use 0, 1, 2. Okay, I get it. So we add here, and then we add here as well, and this one is wrong. That's why we get this. Okay. And this looks pretty, like this actually looks good, I think. So here we have something. We can see the offset grows though, so it's not, it's pretty far from perfect. So let's take a look at the plane variables. Yo, what's up, Cooler SK? Vectors, indeed. Let's take a look at this plane. We have a normal and we have an origin. We have size, but we don't do too much with size in this. Origin, normal, normalize. We don't normalize now when we add it in the editor or when we change it in the editor like this, but we have a normal of 100, so it is normalized, so that's okay. Origin and normal for plane is a-okay. So something has to be wrong with the edge, and I'm thinking, like, I've always thought that it might be the binormal, but v2 minus v1 is correct, isn't it? And it's normalized as well. I don't know. Still worried about this one. Dot product, return false, vector 3 dot, plain normal, plain origin. Yeah, we can delete this. V1 position. So it's very important that this one is the start position, which we're using. It can't. We should, instead of doing V1 position times the binormal or plus T times binormal, we should be able to do this, right? Yeah. It should be the same. Okay, anything else? What more could it possibly be? Actually, we want T, but is intersecting plane, like this one currently returns true even when it shouldn't. So we're not intersecting any plane now. So this one returns true. Like, I mean, the easiest we could just do if vertex. Didn't we have is point on positive side? If v1 or plane dot is point on positive side v1 position, if this one is not equal to plane dot is point on positive side v2 position, or if they are equal, then we could just return false, right? Because then both of the points are on the positive side of the plane. But we need more information. We need a t. Yep. Still wondering about I don't see it. I don't see it. What could we do instead? has to be this one, doesn't it? V2 minus V1 position normalized. But it's nothing wrong with it. Binormal. And we create it here. Oh, could it be? Could it be? Yeah, that's probably it, isn't it? Fuck. Or actually... It's probably the fact that, like, this... means... Or we can go beyond the line length, I think, or the edge length. Or the length of the line is finite. But I wonder if that is the only... Vipinsu, is there any game engine that... but I have no idea. Probably. I think you should ask Google, or better yet, ask an LLM. Oh yeah, of course. But isn't our T wrong? Can we just do it like this? Oops. Yeah. But I'm not too sure that this is the only problem. We'll probably get the correct result here. Did I remove... is intersecting plane? Yeah. So now we get this result at least. That's good. And then we get this offset here. It's fucking weird. Oh, whoa, 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 whoa. Am I? Yes, I might have screwed this up a bit. Oh, fuck, I have. Oh, shit. Okay, so this is under the assumption that we get... This is under the assumption that we get 2 triangles, but we actually get more triangles. Right, this one results in 2 triangles, and this one results in 1 triangle. Oh, wow, wow. That's my bad. Does this explain this? Yes, it probably does. Okay, that's bad. That's real bad. So, triangle, slice. Of course, it doesn't just return this. Would be beautiful if it did, but that's not the case. So, let's change it a bit. Mesh parser slice, triangle and triangles. Now we get this one. Add triangle. Okay, so then I want to do... Hey! Whoa, 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 whoa. Star Platinum, wish you luck, man, see you. Thank you, appreciate it, and have a great rest of the day. Yeah, we're gonna go with the polygon solution again. Trialing in... yes, we are. Or is it over the top? Vertices, triangles... Yeah, we can't do the polygon because we always do it like this. Never mind. Okay, we're gonna do it like this. Public void add triangles. For each triangle. Okay, now my one little assumption I wrongly made lost me an hour. I wonder if we want to do it like this. Let's add this one. Bool, add vertices. Okay, so let's start with edge. Is intersecting this one is correct. We added this and we fixed this. That's good. Triangle slice. Okay, so this one we're gonna fix. We don't return 2 triangles, we return 2 list of triangles. Fuck, do I want a custom struct for this? Maybe later. So before we return here, we're gonna do list triangle positive triangles. If positive vertices dot count bigger than or equal to 3. And then we want to do the same with negative. Actually, can we make it? Yeah, can we make a method for this? Yes. Do we have any static stuff? Static. No. Public static list triangle. Triangulate. If vertices dot count is less than 3, return one sec. Yeah, how the fuck do we want to triangulate this? I can check, but let's see here. Do we want to go 1, 2, 3, 2, 3, 4, so on? Whoa. Oh. Hmm. 0 is that? Yeah, that's probably the correct way to do it. Well, let's do it like that. Very cool. Very, very cool. Okay, let's see what we get with this then. So then we can just do triangle. Or actually, we can do triangulate. Positive vertices. But for the second one, we do negative. Something like that, maybe. And we skip these two. Okay, let's see what we get now. Yeah, we have a problem in mesh parser here because we get lists here. Look how long this is. Add a triangle. Yo, what's up, Iksinski? How's the game going? Progressing slowly, but like we're progressing. So good, I would say. And draw triangle. I want to do draw triangles. Okay, something like this. Please, please. Okay, no change whatsoever. Okay, that's weird. Triangle slice. No change whatsoever. What? Did I fuck up this one? I don't think so. Iksinski, that's great. Haven't been here for a long time now. I was about to say, long time no see. Life is tough, as they say. Indeed it is. Indeed it is. I hope everything is going fine for you. Appreciate it, and likewise. Hopefully life gets a little bit less tough soon enough. Fucking hell, like, we changed from returning just one triangle to multiple triangles, and we got no change whatsoever. What the fuck? You know what? I need coffee for this. I'm just gonna run real quick, so like a couple of 20 seconds, and then we continue. Okay, back. What the fuck happened? Okay, let's see here. Triangulate. Oh. Do we want to do this? Let's see here. If we have 3, then 3, 2, 2. One sec. If we do it like this. Nah. So we're gonna go from 1 to 1, but we add +1 here. How the fuck is it possible that we got the exact same result? Triangle slice, pause, draw triangles. So by doing this, we have currently found 3 errors and fixed them, but none of them fixed the actual problem. Mm. Oh, whoa, 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 whoa. Okay, so what could it be except for these two things? I wanted. Okay, we're gonna print some stuff here. Uh, yeah, positive 1, negative 0 triangles. That's good. And then we'll go here. One triangle. The fuck? How can it still only be one triangle? Okay. That's good at least. Okay, so no, like, one sec. Line and line start. Yes. Ooh. That might actually be... Maybe we don't want to use the binormal here. Maybe we want to use, what is it? V2 minus V1. Because we want it to have a length. If we do it with the normalized and we don't have a start, there we go. Fucking hell. That one was deep. That's for sure. Okay, good. Finally. Okay, makes me want to try this one again, see what we have. There we go. Oh yeah, maybe we need to enable this one as well. Iksinski, hell yeah. We're gonna start with triangles. Hopefully we can cut some cooler stuff soon enough. This one looks good. How about this? Okay. Actually looks pretty good now. Ooh. Is that okay? I think it is. I think it is. Iksinski, interesting that you can split meshes like that inside of Unity. Yeah, I think I tried to work with the, like, nothing is impossible. But this is only the beginning as well. We're gonna I'm looking forward to it. This week, at the end of this week at latest, we will have procedural generation of our first creature, so the stone. And I want to do a visual demonstration where we're gonna procedurally generate a cube or a sphere, and then we're gonna cut it, and at the end we will hopefully have a mesh that looks somewhat like this, right? So it's gonna be real, or this. If we start with a sphere, it might look like this. If we start with a cube, it might look like this. But yeah, okay, so this works, but now we need to fix the cap as well. So let's see if that works. So best case scenario, it's as easy as doing by just enabling caps here. Would be very impressed if it works. Without additional debugging. No errors at least, that's good. Ooh. Yep. Okay, but I think this is not that big of a problem, I don't think. We just need to work with the ordering a bit, I think. So, slice. If we have fill slice hole, then we create a new polygon from slice vertices, and then we just add this polygon. The way we create this one is we create an average vertex given all of these vertices, and then we sort them. Okay, so I think it's the sorting that fucks it up. I think. Because then we just triangulate it by going center vertex, boundary, boundary plus 1, and on and on and on. So it has to be the sorting, right? But I think this is how we sorted it initially. Did we have a center? I think we have a center vertex. Unless we go could it be, nah. This is quite over the top when it comes to triangles. I think it looks more than it is, because I think we have a lot of overlap here. Yeah, it's still quite a lot. Center vertex normal. Should work, I think. The pen, yeah, it should work. Hmm. Mm. The worst part is that when we tested this approach in this solution, then we did it like this, and it worked. edge points, points. So I don't know what the problem is this time around. No. I don't know. Or do I? Do I? Yeah, maybe I do. We don't have any normal on these, do we? Oh. Okay, so when we do triangle and we create vertex here, T. Yeah, we create a normal like this, but that's wrong. Yes. Okay, when we create vertex, new vertices here. For these, slice vertices, we want to do I wonder where I want to do this. Maybe it's best here, but like we need to fix. Okay, I think we're gonna do it here. We're gonna do for each vertex. Yeah, we can't do this. Like we need to do this, the plane and normal here as the normal. So maybe we can do this. Polygons, maybe we can do something here. It's a little bit unclean, but I wonder if we want to do something like this. Polygon. Okay, so we have two options. Either we change the vertices or the normals before, or we do it in here. Or maybe it's just better to do... Maybe we shouldn't even go with the polygon. Maybe we can triangulate it. Triangulate. Triangle. We still need to make the center vertex though. Okay, I think we're gonna do this for now. We can't do this, right? What can we do? No, we can't. Okay. For each. Yeah. Can we do? Or can we do this? Or we do it like this? New. So we do it like this, and then we do. Fuck. Then I want to do call this one here. Oof. You know what? I want to see if this works. So we're just going to take this one, put it here. We can clean it up eventually. And then we take this one as well. And put it here. And then we go back to... Fuck, shouldn't we have an issue here? Plane dot normal. This is the positive one. And then here we have the negative one. Something like that. Okay. Okay. I'm still not 100% sure about my sort here. Honestly, this one. We just take world forward. I wonder if that can come back and bite us. Probably. The compare here. Yeah, maybe. Yeah, we should use the plane here. We should use plane tangent or something like that. But then we're gonna have to send in the plane. But I mean, that's also a good idea. Like, we need to clean this up. Like, it doesn't feel that good. And instead of having it as a polygon, I'm wondering if we're gonna add a triangulate static method. And we triangulate. So this is one way of triangulating, and then we add this other way of triangulating. Maybe. Yeah, I think so. Yeah. Triangulate. Triangulate from... What's a nice word for the first? Triangulate from... I'll triangulate from 0, that's okay. And then we're gonna do public static list triangle. Triangulate from center list vertex vertices. And now I wonder if we can do some real nice stuff here. triangulate from center. If we sort it, we can send it in here. If we add center to the beginning here and we sort it, then we're golden. Can we do link append to that might be pretty vague, but prepend. Prepend. Okay, triangulate from 0. Vertices dot prepend vertex dot create middle vertex, create middle vertex, create average vertex, create average vertex, vertices, and then to list, right? Triangulate from 0, vertices, prepend, create average vertex, vertices. So we just take, we need to sort this shit as well. Fuck. We do it like this then. Riley Harlow. Okay. Whatever, man. We want to create this average vertex, but we also want to sort the rest of it. Like, is this weird? So prepend, we're going to do that, but we also want to do sort. Iksinski AI is for sigmas. Yeah, should put it on the wall. But I don't want to use sort here. Link sort method similar to list.sort. If you know how to use it and not generate slop code, like, you have to know the limitations and stuff like that, and definitely review it a lot. Yeah. Order by, and then we just do order by descending, but there we have a compare. This is what I want. But fuck, can we do... Yeah. Dot order by v dot... Okay, this one is quite long though. And here we use... Where do we have it? This one. But then we do compare to, although I want angle A. Yeah, why do we do it like this? Can't we just calculate this one and order it like that? So I'm wondering, couldn't we do... we need to get... Yeah, we need center vertex here. Yeah, maybe I was a little bit too optimistic by making this one as nice as this. Ah, that's unfortunate. Oh, that's unfortunate. The only reason I don't want to do... Like, we could do... And then we use triangulate from 0, sorted vertices dot prepend center vertex dot to list. Like, very unoptimized, but it should do the work. So we create the center vertex, we sort the vertices based on this, so we go clockwise, and then we add the center vertex first to this list and send it in to triangulate from 0. And here we just loop through the list from index 1, and we do 0, 1, 2, 0, 2, 3, 0, 3, 4, and so on, so on, so on. But what sucks with this solution is that I also want to create a method like this: public static list triangulate. Actually, let's just copy this one. And vector 3 override normal. And if we're going to override the normal, we need to fix all vertices, which means that we're going to loop through loop through it again. I eat this. Oops. So, which means like extremely unoptimized, but and then here return triangulate from center. Vertices altered. Yeah, triangulate from center. So here we loop through it, and here we loop through it. We create a lot of extra. Yeah, it's memory heavy and unoptimized, but it might just work. Let's see if we can. Let's see if it works. So in Mesh Parser, instead of doing add polygon, I think we want to do positive dot add triangles, and here we do triangle dot triangulate from center, slice vertices plane dot normal. You see, so pretty much the exact same thing, but I think it's a little bit nicer. It looks better here. And then again, yeah, we can go back and optimize this if we notice that it's way too slow, but we're probably going to do this on a secondary thread, so we have a little bit more of playroom. Like, we're not going to do this in real time in every frame. But let's see if it works, first of all. Almost. Almost. And I know why. We don't do the last triangle. Because, fuck, this is gonna look beautiful when we use this to procedurally generate our creatures. Fuck yeah. We don't add the last triangle, because when we do triangulate from 0, we just go to vertices count -1. Because let's see if we can draw this real quick. One, two, three. So what we do is we always have 0 as a base, and then we do 0, 1, 2, and that's our triangle. So naturally we do like this, and then we just add 1 to the indexing. So 0, 2, 3. Let's do it like this. Bam, and then we're done. If we do it with the center point, let's do 0, 1, 2, 3, 4, 5. We do 0, 1, 2, 0, 2, 3, 0, 3, 4, 0, 4, 5. And that's it. I mean, it's not that big of a problem, but like if we want to keep it, if we want this one to utilize this one, it becomes a little bit messy. I think we're gonna do, yeah, we do it like this: bool include or wrap around. False. If wrap around, then we do something else, we do something else. And I'm actually gonna put these like this. And then we need to add this, I think. And then we do 0 I j. Oops. So if we go to vertices count, then becomes 0, then it becomes 1. Yeah, I think something like this. Let's try it. So wrap around here is true. Did I fuck up? What? Does this one become... Yeah, of course. Yeah, this one sucks. So if this one is vertices count -2, then we're screwed. So what do I want? What do I want? I guess we could do... Right, so if it becomes 0, we take... or max, I mean. And there we have it. Great. Okay, this is a great starting point for tomorrow. Unfortunately, I need to run now, but I think it was productive. We spent a little bit too long on the triangulation or splitting of triangles. But other than that, all good. Thank you so much for watching, everybody. Appreciate it. And have a great rest of the day. Peace.